Mason. I'm a principal consultant at InfinityWorks, who are now part of Accenture, which I have to say. I've been in software engineering for around 20 years now, formerly specialising in .NET development. Past few years, more Node.js, full-time JavaScript. I'm also fairly experienced with public cloud architecture, so I was doing AWS from about 2014, switched to GCP in 2018, now back in AWS again. Before I start, I just want to say thanks to everyone who's organised and attended this. I've been doing this kind of thing remotely for 2 years, and it's rubbish compared to this, to be honest. So it's great to be back in the room with everyone, and I really appreciate the effort. So, QLDB. I recently became aware of it while researching data storage options for a client I'm working with. And although it's been around for getting on for 3 years now, it's not been widely adopted yet. I've done a lot of reading, I've spoken to other engagements within InfinityWorks who've assessed it for clients, and I've actually used it. So I thought it maybe fit nicely into a future tech event. Probably something you should consider for projects that you might be working on. So what is QLDB? The easiest way to explain QLDB is think of it as blockchain, but without the distributed element. So what you do get is an immutable, cryptographically chained ledger that can be verified by third parties if you need to, but you don't have the concept of distributed nodes voting on changes. There's one central source of truth. So if an organisation is considering blockchain, so they can get a ledger of changes, but it's the data that they actually own themselves, the odds are that what they need is something like QLDB. So there's loads of examples where this kind of data storage is handy. At InfinityWorks, we've considered QLDB for, so the client I'm working with is an online gambling company. They've got events coming out of their platform. It's a heavily audited industry. They need to be able to prove beyond doubt that a certain chain of events have happened, or perhaps someone's disputed whether a bet should have been paid on or not. This is a way that you can say, without any shadow of a doubt, this is actually what happened and we can prove it. We've also looked at it for storing transactions, for a sort of loyalty scheme for a major UK retailer. And we've looked at it for actually creating a financial ledger as well for sort of double entry, immutable accounting. But there's plenty of other examples as well. Reconciling supply chain systems is a big one. So looking at recording the history of manufacture, batch, shipping, sale, maintaining insurance claim history, or tracking people's details in an HR system. All of these are scenarios where it's useful to be able to prove beyond doubt that at a certain point in time, this is what your data look like. So how does it work? You actually work with it in much the same way that you do all the data stores. Behind the scenes, it's working quite differently. So when you perform any data change in QLDB, an entry gets appended to a ledger. And that ledger can then be cryptographically verified, which I'll get onto that in a minute. Querying the ledger itself isn't that much used for business applications. So it also provides a current view of the data, which you can execute queries against, and it includes a history function that allows you to view all of the state changes within the data within a certain time window. And it uses a document-oriented data model, so it supports structured and semi-structured data as well as nested objects. It shares a lot of concepts with relational databases. This diagram that I've pinched from the AWS documentation shows how these concepts map to each other. So at the very core of things, the ledger is the database. And one of the key things to call out here is that rows are stored as an ION document, which is Amazon's extension to JSON. So JSON validates as an ION document, but ION gives you like type support, and it's got a very efficient binary representation as well for storage and transmission. And in a relational database management system, you'll have audit logs and transaction logs. They get replaced by the journal in QLDB. The key difference being that audit logs and transaction logs, they tend to be quite transient. You close them down, you do backups, they're very difficult to query. Whereas in QLDB, the ledger is the very core of the database. It's immutable and it's permanent. So the query language that it uses is called Particle. It's a new open standard query language that supports SQL-like access to a document-oriented data model. You might already be familiar with it if you've been working with DynamoDB. The SQL element of the language allows you to perform selecting, insert, update, and delete operations and run cross-table joins. The queries on this slide demonstrate how SQL has been extended to support semi-structured document queries. It also provides ACID transaction support. In a nutshell, that means if you've got a set of tasks that will run, you can run more as one transaction, and if any part in that process fails, the whole thing will roll back, which is really important for a lot of transactions that we probably deal with on a day-to-day basis. A good example is withdrawing money from a bank account. You can imagine there's lots of steps in that process. If any part of it fails, that's not the kind of thing that you want to leave in a half-completed state. So it will roll the whole thing back, and that's what we mean by ACID. As well as running the kind of basic queries shown on that last slide, you can also query the system metadata that QLDB generates for each document you store. So every document gets assigned a unique document ID when you create it, which is the unique identifier for the record. And then you can query from this QL committed view that it creates automatically for every table that you have, that will give you things like the transaction information, the journal attributes, and the document's hash value, crucially. And you can treat that document ID in the same way you would any other unique identifier, so you can use it as a foreign key in other tables and then join to it and sort of ensure your use and so on. What this shows you is the tiers to QLDB storage system. So you can see down there at the root level, that's where you have the journal, which is a linked list of every change that's ever been made to the data in that ledger. And then above that, you have the history view. So you can see there we've got record ID 1, but it's got version 0, 1, 2. So it shows you what state the record was in within each version. And then at the top you have the current view. So most software that we write, we're interested in what the data looks like now. So is the current view that you'd be interested in querying in that scenario. So what actually happens when you write to QLDB? This picture actually shows quite nicely what's going on. So in the first transaction, I've got a table called cars. I've written a record to it with a make and model, a year and a bin. And what happens is the journal records that transaction, and then it generates a hash using the SHA-256 algorithm of that transaction and stores it in the journal. So if any change is made to that transaction after that hash has been generated, the hash will no longer validate. What I've then done is I've updated it. So I've added an owner, because we've sold the car now, so we've got an owner. And although it's an update, what's actually happened is we've appended a transaction to the ledger, and we've generated a hash of that transaction that includes both the transaction and the hash of the previous transaction. So at that point, if any record in the ledger changes, the top level hash won't validate. And then we've deleted it for reasons. And again, we've taken a hash of that. There's a hash of the transaction and a hash of the previous transaction. So again, now we've got a chain of 3 things that have happened. If any change happens in that chain, the top level hash won't validate the chain, and we can prove that. And QLDB actually exposes an API you can use to validate journal entries if you're ever required to, such as for an audit, for example. So how do you actually verify the data that's in the ledger? So the first step is to request the digest, which you can do fairly easily. You can do it through the console, do it through the CLI, do it through a number of different SDKs. In the data that you can see here, the digest, that top bit, that's the hash value of the digest itself. The digest tip address is data about the latest block. So it's got the strand ID, and it's got the sequence number, which is sort of how many records are in the ledger. A strand is like a partition of a ledger, but interestingly, QLDB only supports one strand, so there will always be one strand ID for your ledger. And then it's got a name, and it's got a timestamp for when that was requested. Step 2, we then need to get the ID and the block address for the document we want to verify. So that QL committed metadata view that I was talking about before, you can query that, you can filter it based on some data about the actual record, and it will give you that actual ID and that block address. And then finally, there's a handy little form in the AWS console. So you can take the values from the digest, you can take the document ID and the block address, you plot them in there, hit verify, and it will verify it and prove whether it's correct or not. And actually, if you go into the documentation, it will give you the very detailed steps of how it does that verification. So if you didn't trust Amazon for whatever reason, you just wanted to verify it yourself, you can do that, and the SDKs make this verification available as well, so you can build it into your own software if that's the thing that you want to do. There's a number of other useful features about it. It's completely serverless, so there's no underlying infrastructure that you have to maintain, which saves a lot of operational complexity. I find that when AWS calls things serverless, there's a bit of a spectrum, like, you've got sort of managed Kafka at one end, where it's still going to spin up all your broken nodes and you've got to look after them yourself, and at the other end you've got something like this, where it is quite literally just a service that you use. It's very durable. When you create a QLDB in AWS, the ledger will be distributed across 3 different availability zones, and you'll have multiple copies of that ledger per availability zone. So you don't have to worry about some disk failure in an Amazon data center causing you to lose your ledger. Just due to it being a central source of truth, rather than a distributed model like blockchain, writing a change to the ledger is a lot less work. So, according to Amazon at least, you can expect to see 2 to 3 times the performance from the QLDB than you would using a blockchain for managing the same data. The consumption-based pricing model is based on read-write I/O and total storage. So you can start small with it and spend basically nothing. So when I was messing about with it, I put it into my own personal AWS account, so I picked up the tab for it. It cost me £9 for all the weeks I was doing to sort of figure it out as a POC. However, you can also go very, very big. So the client I was looking at it with, we were looking at, I think it was 1 million reads a day, 2.5 billion writes per day, approximately 9 terabytes of data per month, and that came to about 60,000 so you can go it supports streaming to Kinesis, which is incredibly useful. So you can then write data to other services. That works well if you've got, say, an event-driven architecture, or if you wanted to get real-time insights on the data, so you could stream it out into S3 and then use something like Athena or Amazon MapReduce to do sort of big real-time data queries on it. And usefully, you can replicate the data to other data stores in AWS. So a good use case example for that is you might have a QLDB as your sort of transactional database. You could replicate the data into Elasticsearch and do sort of full text searching within your application as well, and sort of get that for free. So that's all the good stuff. Drawbacks and limitations. So now I've explained what it is, how it works, what you can do with it. Let's talk about what we found when we considered it for actual client projects. It is a relatively new technology. There's always going to be drawbacks and limitations with anything this new, and you need to figure those out before you decide whether you want to actually use it or not. First and foremost, At present, there's no way to back up and restore your data. Now, I do understand why a feature like this is harder to implement for something like QLDB, but in all honesty, that's a massive, massive oversight. And it probably goes a long way towards explaining the lack of take that we've seen on this so far. You can export your journal to S3, and then you can create a new ledger from that journal, but that's not really a proper substitute for a decent backup and restore process that you would implement with a normal relational database management system. There's also no point-in-time rollback, which I find bizarre because surely this should be the easiest of all the database technologies to do point-in-time rollback. I'm sure everybody here has got a horror story about an either dev or an analyst that's missed a layer, pulled off a query and accidentally wiped out a chunk of data. If that happens in QLDB, you've got very, very little chance of recovering from that. The feature is on the roadmap, but there's no sign of it just yet. You can only deploy it to a single region, so if your project requires multi-region failover, it's probably not a good solution for you. You could technically replicate QLDB into another QLDB in another region, but that's going to be horrendously expensive because of egress costs, so that's something we probably need to look at. The streaming events we found out were particularly useful. So we've used DynamoDB streaming quite a bit to say, here's a thing that's changed, and then doing some kind of process downstream as a result of that change. The events that come out of QLDB, it's more about the ledger metadata than what's actually changed. So to get anything useful from the event, you've got to have something read the event and then send it back to QLDB to get the data that you need. If you're using that for an event-driven architecture, that's a really bad pattern, because then your event handler becomes dependent on your event source being available. This next one is insane. I suspect that QLDB is based on the same technology as DynamoDB, and if you work with Dynamo, you'll understand that you have to worry about optimizing your indexes for good query performance. However, if you run any kind of inequality operator in the where clause of a query, so greater than, less than, between, like, it's not going to use the index, it's going to do a full table scan. And so if you've got any kind of data volume, you're probably going to get timeouts. You've got 30-second transaction time limit by default, because it's ACID, it does sort of concurrency stuff, so the longer your queries run, the more likely you are to get concurrency conflicts. So, to give you an example, if I had a table of people and I wanted to get everyone under the age of 30 by looking at their date of birth, I'm probably not going to be able to do that, which is a pretty huge limitation. And there are some pretty significant limitations on the particle language support as well. So particle does, like by default, does support order by for ordering your queries, and limit and skip for pagination. You can't do either of those with QLDB. So there are some pretty significant limitations that are either going to completely rule out, or you'll have to think about how you work around. So, in summary, there are plenty of real-world examples where a cryptographically verified ledger is going to be useful, and QLDB should be seriously considered as an alternative to blockchain where the data is owned by one entity. However, it's clear from our investigation into it that it isn't the technology that's ready to be a standalone data store yet as part of the business's technical architecture. So if you've got a ledger, if you've got a specific requirement for a ledger, I'd recommend treating QLDB as a downstream consumer of changes and use something like Aurora or DynamoDB as the storage layer for your apps and services. There we are. Thanks very much.